Hi everybody, this is lesson 1 of chapter 5. Let's go through this quickly and then you can get on to some practice. We will review this material again next class. So, lesson 5.1 is simplifying algebraic expressions. A little recap, if you remember from grade 7 or grade 6, when we talked about algebra, it was this type of math where we used letters to represent a variety of numbers. They're kind of placeholders for what could be numbers of all kinds. So we use these letters and we need to know how to play with them using math. So let's get into it. So the goal is to simplify expressions by combining like terms and applying integer rules. Just to start off, I'm gonna write a term, and we're gonna use this as we walk through the vocabulary. So this term is gonna be 5x squared. Okay, 5x squared. So we'll refer to that. Let's go through our vocabulary. So the first term we're going to talk about is algebraic expression. An algebraic expression is a mathematical phrase that contains variables, numbers, and at least one operation. And our example is 2x plus 5. 2x plus 5 would be considered an algebraic expression. In this case, we have two terms. 2x is a term, 5 is a term, and it's separated by this plus sign. That's our operation. Next is a monomial. It's an expression with one term, and we have three examples of monomials. So x is a monomial, negative 3x is a monomial, 7 is a monomial. And this term that we wrote earlier, so that too is a monomial. So 5x squared is a monomial. A binomial is an expression with two terms. So that first example when we talked about algebraic expression, that example itself was a binomial. So 2x plus 5 is a binomial because it has two terms, just as 4p minus 9 is a binomial, as it also has two terms. The coefficient is the number multiplied by the variable. In the example we have above, 5x squared, the coefficient is our 5. Our 5 is our coefficient. Okay? And it's worth labeling it. So this number in front of the variable will always be called the coefficient. Coefficient. Okay, and when you see that number in front of the variable, it means 5 times whatever that variable is. So in between the 5 and our variable is it's considered multiplication. Next are like terms. Like terms are terms that have the exact same variables raised to the same power. And our example would be 5x and negative 2x. Those are both like terms because they have the same variable, which is x, and they're raised to the same power. So the power on that x is 1. And that's why those are like terms. Let's give another couple examples below. So 3x and x are like terms. They are both like terms. Okay, one thing to note. So our x, when we see x all by itself and it doesn't have a number or a coefficient in front of it, it really just means 1x. It's the same thing as writing 1x. And that's important to know because if you're adding these two, so 3x plus x is going to give us 4x. So next, another example, let's see, 2x squared and let's see, 4x. So these two terms, are 2x squared and 4x, are not like terms. And they're not like terms because the power on our variables is different. So the variables are the same, which gets us halfway to a like term, but they have to have the same exponent on those variables. So those are not like terms. So they need same variable, same power. All right, let's get into a few examples. So it says to simplify, we must combine like terms. Okay, to simplify, you combine the coefficients using the integer rules you learned in chapter 4. So let's take a look. So example 1. So it says simplify negative 2x plus 5x plus 2. And our first step is to identify the like terms. And in this case, our like terms are negative 2x and 5x. And we have our operation in between these two is a plus. So in order to simplify here, we need to add these two together. So negative 2x plus 5x. We would do that by combining the coefficients. So negative 2, we could say negative 2 plus 5 is equal to 3. And we can combine this negative 2x plus 5x to get 3x. And then we rewrite this simplified expression, and we get 3x plus 2. And we have to stop there. So we cannot, there's no way we can actually add 3x and 2 together because they don't have the same variable with the same exponent on it. So again, we identify the like terms. Our like terms are negative 2x and 5x. We add the coefficients together. Negative 2 plus 5 gives us 3. And so those two terms combined give us 3x. And our simplified expression is 3x plus 2. Let's do this again. Example 2 says simplify 8x minus 4x plus x. Well, we'll identify the like terms. The like terms here, they're all like terms. So they all have an x variable. And the exponent on those x variables is 1. Okay, so those are our like terms. We now need to combine the coefficients. And when we do that, we just take our 8 minus 4, subtract 4, and then add 1. So remember, this is the same as 1x. So when we see the x by itself, it just means 1x. So we'll combine those coefficients. 8 minus 4 gives us 4. 4 plus 1 gives us 5. And we can rewrite this as 5x. Okay, it really just means 8x minus 4x plus x is equal to 5x. And I think it's worth writing that out. I'll write it out in different colors. So 8x minus 4x plus x is equal to 5x. All right, let's do this next one. It says simplifying expressions with binomials, meaning brackets. Now it has this little rule underneath it. It says associative and commutative properties. So these properties say this. They say that changing the order of multiplication or changing the order of addition does not change the result. So if we have a whole bunch of numbers that we're trying to add together, we can change the order of those numbers as long as we maintain addition between them, or as long as we maintain multiplication between them. We can change the order and get the same result. And we can use that here. So we have these two binomials. So one is 4x plus 3y. That's one binomial. The other one is negative x minus 2y. Well, so these commutative properties, so they're suggesting that changing the order, in this case, the one which really matters to us is changing the order of addition. Changing the order of addition. If we remember our rules, our integer rules, we could do this. I'm going to rewrite this so that we have addition between all the terms. So we get 4x plus 3y plus negative x, or negative 1x, plus, so remember, if we have minus 2y, we can also say it's plus negative 2y. And we got this from our last class, where we talked about the fact that if we had 3 minus 2, okay, that equaled the same thing as 3 plus negative 2. Okay, and in this case, so both of those equal 1. Now in this case, what we've done is we've created an expression, okay, with 4 terms, and we are adding them all. And so changing the order of this addition does not change the result. So let's first identify our like terms. So 4x and negative x, those are like terms because their variables are x, and the power on those variables is 1. And then we also have 3y and negative 2y. Those are like terms because they both have y variables, and the exponent on both of them is 1. And so let's change the order to something which helps us add and subtract our like terms. So I'm going to move that negative x. I'll write out my 4x plus negative x. And I'll write negative 1x because it makes things just really obvious with what we're supposed to do, plus 3y plus negative 2y. So I've grouped our like terms together, and we'll do the addition. So this first set, so 4x plus negative 1x, we do this, 4 plus negative 1, and we get 3. And so I can replace those with 3x, plus we get 3y plus negative 2y, so 3 plus negative 2 gives us 1. And so we're left with 1y, or just y, 3x plus y. And we've simplified this expression and completed example 3. Okay, you should be able to complete chapter 5, practice 1, and we will review this again in next class. Thank you.